Welcome back to the Foundation in C# course. We are currently in Module 8, and this lesson we're going to cover basic normalization. Now, because this section is all about different SQL databases are relational databases. And with relational databases, we talk through the idea of normalizing those relational databases. So I want to take a minute to kind of go through what is normalization, why do we need it, and how are we going to normalize our database. Okay, so let's talk through the basics first. Normalization is the process of reducing or eliminating redundant data in your database, which also improves data integrity. Okay, so there's two different pieces of normalization. One is a reduction in redundant data, and two is an improvement in data integrity. And those two kind of go hand in hand. The idea is that if I store my first name in a database in 3 different places, and I have a change in my first name, I go from Tim to Timothy. Well, if I change that in one location, now I have a mismatch in the data. There's a data integrity problem because my name is Tim in one spot and Timothy in another. That's a problem. And so this reduction or elimination of redundant data helps us make sure that we're storing things once and we're just referring to it in multiple places. Okay, so how does this apply to our database? We're going to do it in 2 steps. We're going to look first where our data is and then take it one step of normalization and then the second step. Now, you may have heard of the steps of normalization. There's 5 levels of normalization. So first normal form, second normal form, third normal form, and so on. Typically, databases are in around the third normal form. That's kind of the sweet spot for the theoretical design of the normal forms. Our database will be in that third normal form, but we're not going to have to apply a lot of things to be the third normal form, okay? So we're not going to get into theory here. We're going to get into practice. So while it does conform to about the third normal form of database design, that doesn't mean that we're going to go through all 3 levels. We're just going to go through 2 stages of kind of reducing that redundancy of data and improving the data integrity, okay? So that's what we're going to do today. So, step 1. On the left here is what all of our data we have. So, first name, last name, address 1, email address 2, phone number 1, phone number 2, and I put last name and full name there, just kind of as examples, okay? So, and really email address 1 and 2, what happens if I have a third email address? Well, if I had been used this table on the left, I have to add a new column. See, each of these entries is a column in our database or our table. So first name, last name, email address 1, email address 2, now email address 3. And what if you have a fourth? Well, now you have a 4th column. And so your number of columns is large really quickly. And then at the end, I have last name and full name as 2 examples of repetition. Okay, where maybe you put it in the column again for whatever reason, and then also last name, but also full name, where full name is your first name and your last name, the space in between. Well, isn't that redundant? Because then if my full name is Tim Corey, my first name is Tim, my last name is Corey, and then I change my first name to Timothy, I have to change full name as well. Otherwise, I have first name Timothy, last name Corey, full name is Tim Corey. See how there's a redundancy there? So that's on the left what we start with. It's just, here's some things we need to capture. On the right is our first take at kind of breaking these apart into different pieces. Okay, so the contact table. First of all, we're going to add an ID. wise idea to use natural keys in most scenarios. I'm not saying never use natural keys, but I'm saying default to the idea of a surrogate key unless you find you really have a good use case for it. Okay, so that's the ID. So contact table has ID, first name, and last name, and that's it. Because that is unique, and that's a set of data that is not going to need to be duplicated in any way. So you're not going to have the idea of a first name and last name and something else. They have to be connected together necessarily. Okay, it'll make more sense as we go on. But notice that there's not a full name and there's not a last name twice in that contact table. But that's all we're storing there is those three values, the ID, first name, and last name. Now we have a second table called email table. It has an ID, again, that's surrogate key. And then we also have a contact ID. And what this is a foreign key that relates back to the primary key in the contact table of ID. And why do we have this? Well, this is a link between these two tables so that the last field, email address, let's say I have a contact record for Tim Corey. So ID of 1, first name of Tim, last name of Corey. In the email table, I can have an ID of 1. I can have a contact ID of 1 and an email address of tim@imtimcorey.com. Now we'll link the contact ID of the email table to the contact table's ID. And now we know that Tim has an email address of tim@imtimcorey. But here's the cool thing. In the email table, we can add a second row. So ID of 2, contact ID of 1, an email address of me@timothycorey.com. So now we have two entries with email addresses that both use the contact ID of 1. Both of those rows link back to the Tim Corey record in the contact table. So now we have a one-to-many relationship. One entry in the contact table can have many entries in the email table, or none. The same is true of the phone table. We can have many entries in the phone table that all link back to that contact ID number of 1. So one contact record to many phone number records. Okay, so that's our first step of normalizing our database, but we're not done yet, because what happens if I have a phone number, a home phone number, that is the same for both me and my wife? So my wife is the second record in the table, so ID number of 2 and first name and last name, okay? But she has the same phone number as I do, or for our home phone number. So in the phone number table, it has contact ID for a phone number. So a phone number is 555-1212. Okay, so that's in there, and it has a contact ID of 1 because it refers to my phone number. But my wife Charity comes along and she says, well, I have a phone number called 555-1212. How do you reference that? Because it's a one-to-many relationship, meaning there's only one record in the contact table that it links to. So the same record in the phone table can't point to contact ID number 1 and contact ID number 2. So now you have a duplicate record. You have two records in the phone table that both have a phone number of 555-1212, but one has contact ID number 2 and one has contact ID number 1. That's not ideal. So let's go on to the second step of normalization for us. On the left is where we ended up in the last screen, and the right is what we're going to do to change that. So now you notice that in the email table, there's just an ID and email address. The phone table is just an ID and phone number. There is no contact IDs in either of those tables. So now we have a list of email addresses, we have a list of phone numbers, and we have a list of contacts, but there's no relationships yet between them. That's where the last two tables on the right come in. The contact email table, okay, that says that this contact ID points to a contact record. This email ID points to an email record. Okay, and notice it also has its own unique identifier as well. Now, what does that do for us? Let's go back to our scenario. Let's do it with phone number. The phone number is the same thing. Okay, so let's go back to our scenario of the idea that the my record is 1. My name is Tim Corey. My wife's record is 2, Charity Corey. Okay, so we have 2 records in the contact table. In the phone number table, we have 555-1212, and that's, let's just say, phone record ID of 5. Okay, that's the ID. So how do we associate that phone number with both my account and my wife's account? Well, we have a record in the contact phone table that says contact ID is 1. Phone number ID is 5. Okay, so now I have associated the contact of 1, which is Tim Corey, with 555-1212. Now, let's add another row in the contact phone table for my wife. Contact ID is 2. Phone number ID is 5. The same phone number. Okay? And now Charity is linked to 555-1212 as well. Okay? So now we have 5 tables. Whoops. We have 5 tables that represent our data. Okay? So where we started with just having this one blob of data, we've now broken it apart into 5 different tables that link together with a many-to-many relationship. That way we can have a contact that has a phone number that is shared with somebody else, and we can have a contact with an email that's shared with somebody else as well. So this is all theory, and we're going to put it into practice 3 times with our different SQL databases. So SQL Server, SQLite, and MySQL. So you're going to see this over and over again, but I want to get you ahead of the curve a little bit and have some of this theory down so that maybe you can come back and look at this later and say, okay, I got it. I can kind of see now how the theory is applied in practice. Okay? So that is our normalized database on the right. It's simple, but at the same time, it's got some complexities to it. Okay, so the pro tip is the normalization forms are guidances, not rules. Do what makes sense for your scenario. So I talked about the idea that technically this scenario on the right is the third normalization form. Okay, third normal form. But there's probably some debate on that because in theory it might even be a second normal form because there's not a reason to apply the third normal form. Okay, that's all theory. Don't concern yourself too much with theory. What you want to get away from is the idea of what we have on the left over here, which is email address 1, email address 2, oh, I have to add email address 3, and so on. You want to get to the point where your database reflects how your data is represented. If you say, you know what, we're never going to have 2 people that use the same email address or the same phone number. And there could be a case for that. Some scenarios there might not be a shared value like that. Then what we have on the right is overkill. What we have on the left is more like the direction you want to go. So even though the normalization forms are there and you can kind of study them, go through all 5 forms if you want, and that's just overkill in my mind, the idea is you need to take a pragmatic approach. The approach is what works the best for my scenario, okay? So do what makes sense for your scenario. Don't just say this guidance is a rule, okay? Make sure that you separate out guidance or best practices from rules. There's honestly very few rules in software development or database development. There are some, but in general, they're more guidances. And your scenario may involve violating one or more of the rules. And that's okay, as long as it makes sense for your scenario. Okay, so your homework is to take our final database structure and then on paper, add a few contacts to the database. See how it works in theory, okay? So I'm really big on the idea of planning before you build. Making sure on paper that it works before you start putting it into an actual structure. Otherwise, you'll work yourself into a corner. So get out a piece of paper, take the structure we have here on the right, and make them into little spreadsheets, okay? And then put data in them and using your own numbering. So like auto-incrementing ID. So it's 1, 2, 3, 4. You can figure that out, okay? Just fill it in automatically for yourself. But write on paper and then start doing the linking and see how that linking will work, okay? So you have a better understanding of how this structure works in theory. And then we'll get into how do you make it work in practice in the 3 different database types that we've chosen for this section, okay? So get that done. Please, please, please do the homework before you move on, okay? There's a reason why I don't provide the homework. I may at some point, but I don't provide the homework because I do want you to do it. I do want you to struggle through it. I don't want it to be just a, yep, I got it because I looked at what Tim did, okay? You need to do this because at some point in the real world, you're going to be given a task without the answer key. You need to be able to work it through. The way I do that is to practice now, okay? So practice this before you move on to the next lesson.